Well, in this lecture, I try to clarify the concept of Squre test and with some numerical example, the concept will be clear. Okay, so you know the like the t distribution, the chi-square distribution is a family of similar probability distributions. Each specific chi-square distribution depends on its degrees of freedom. There is a chi-square distribution with 1 degree of freedom. There is a chi-square distribution with 2 degrees of freedom. There is a chi-square distribution with 5 degrees of freedom, and so on. And if you like to have some understanding over this concept, you can go to the other videos of mine and clarify your concept. So here, a sample of size n to make inference about population variance, the appropriate chi-square distribution has n minus 1 degrees of freedom. Okay, and now look at this. How tables of chi-square values can be used to make inferences about the population variance. Consider a situation where the sample size is 20. Therefore, the degrees of freedom is 19 because 20 minus 1 is 19. A graph here, you can find the 19 degrees of freedom chi-square distribution, and you can find that the chi-square values are between 8.90655 and 32.8523. It means that when a random sample is selected from a normal population, okay, there is a 95% probability that the chi-square value will be between this and this. Clear? For example, the area under the curve to the right of this, that is chi-square 0.025. Look at this, chi-square 0.025 is 0.025. This area. This point represents the chi-square 0.025, and this area represents 0.025. Okay. Thus, you can say chi-square 0.025 corresponds to a chi-square value in the upper tail of the distribution, this area, upper tail of the distribution. In the same way, chi-square 0.975, chi-square 0.975, look at this, chi-square 0.975, and this is the chi-square 0.025. Okay, so in the same way, the chi-square at 0.975 means the 97.5% of the chi-square values. Okay, 97.5% of the chi-square values are to the right of chi-square 0.975. This, okay, to the right of this, So this is the pictorial presentation. Now I am going to clarify the chi-square test with an example. Look, here a die was rolled 104 times. Okay, a die was rolled how many times? 104 times. The outcomes are given. The outcomes are given here, given in the following table. And conclude if the die is far or not using, if the die is fair or not using 1% significance level. Okay. Now, if you add the frequencies, these frequencies, if we add these frequencies, then 101. Okay, this is 101. So I like to increase this value. This is 26. Okay. Now, if we count the sum, 104. So this 104 is 104. So a die was rolled 104 times. The outcomes are given in the following table, and you have to conclude if the die is fair or not using 1% level of significance. And also here the critical value is 15.086 at 1% level. Okay, at 1% level. Now, so this is the formula for calculating the chi-square, that is summation of observed frequency, expected frequency, observed frequency minus expected frequency, and whole square of that, and divided by the expected frequency. Okay, so we have the observed frequency, but we do not have the expected frequency. So before going to calculate the expected frequency, we have to select the null hypothesis. We have to select the null hypothesis, and here I am writing the null hypothesis is zero, H0, die is fair. This is the null hypothesis. Okay. Die is fair, and the null hypothesis H0, and alternative hypothesis is die is not fair. Okay, but die is unfair. This is the alternative hypothesis. HA is the alternative hypothesis. Clear? These are the two hypotheses. Clear? Now, null hypothesis means the observed values are close to the expected values. It means null hypothesis is fair from where you can conclude when the observed values are close to the expected values, and when you will accept the alternative hypothesis, and when you find that observed values are not close to expected values. Okay, so this is the null hypothesis or alternative hypothesis. Now you know this is the in formula I have mentioned the frequency, observed frequency, and expected frequency, and after putting the values in this chi-square, we will get the calculated chi-square. Okay, and if the calculated chi-square value is less than critical value means 15.086, it is given at 1% level, critical value, then you should accept the null hypothesis. Otherwise not. Okay, otherwise not. So we have to now calculate the expected frequencies. So there is 1, 2, 3, 4, 5, 6, and we have to equal to 104 divided by 6 equal to 17.33. This is a fraction. Okay, 17.33. 104. 17.33. And now I like to make it the full number. So I can change some values here. And 104 and 104, it means 4. It should be 2. It should be, if it is 2 and make it 4, then it is 102. Now it is very easy to make a calculation. So I have changed the data. So 102, it means, look, 102 divided by 6. Okay, it is now just a moment. Just a moment here. So look at this. So here 70. 70 is the expected value. In the same way, for 2, it is also 70. For 2, it is also 70, and for 3, it is also 17, and for 4, it is also 17, and for 5, it is also 17, and for 6, it is also 17. That is the expected value. Out of 102 times 1 will appear 17 times. It is expected because total number multiplied with the probability. Multiplied with the probability of that number, then we get the expected value. Okay, so in that the 17 is the expected value. Now I copy it and paste it, and here it is observed frequency, it is the expected frequency. expected frequency. Expected frequency is 70. Okay, 70, 70, 17, 17. Clear? So this is the option. So we have clear. So now we should follow the formula. The formula is here is that we have to take a difference of this and then the square of it. Okay, I am taking now I am and paste here. Okay, and this is the observed, and this is the expected. Okay, this is the expected. Now, following the formula, equal to this minus this minus 6. And if I drag it, then I get all the numbers. Now I have to take the sum, the square of it, square of it. Now I am taking the square. This star multiplication sign again. Okay, 36. Now this value. So I have this value. Now we have to divide it by expected value by 70. Each of these. Well, this divided by 17. Okay, so this is the value. We are getting each value, squared value is divided by the 17. So now we have to take the sum of it because the formula, in formula there is a summation. So we have to take the sum of it. Enter 8.2352. Okay, so 8.23, 8.23, 8.23, 5294 is the test statistics. Is the test statistics. Okay, this is the test statistics. This is the test statistics. And if we go to this curve, then this point represents, this is the chi-square distribution, and this point represents the critical value. Okay, and this is the rejection region. And if our calculated value, chi-square value, which is 8.23, it is actually less than our critical value, 15.086. So this is the critical value, 15.086, this point, and 8 is less than this. So in this region, so we conclude that as we can write in this way. Okay, we can write in this way as 8.2352941 is less than 15.086. 15.086. We accept the null hypothesis. Okay, we accept null hypothesis. Clear? As I have mentioned here is that, as I have mentioned that if calculated chi-square value is less than the critical value, then we should accept the null hypothesis. So we should accept the null hypothesis. What is the null hypothesis? Null hypothesis is that die is fair. So die is fair. In this problem, we conclude in this way that the die is fair using the chi-square distribution. Now, the second problem. Look, a headmaster of a school would like to know which days of the week students are most likely to be absent. The headmaster accepts the students will be absent equally during the 5-day school week. Okay. Selecting 100 teachers for asking them which day of the week they had the highest number of students absent. The observed results are shown in the table. Based on this, do the days for the highest number of absences occur with equal frequencies. Use 5% significance level and critical value at 5% level of significance is 9.490. Okay, 9.490. So this is the problem. So here you know we have to, in the same way, this is observed value, and now I'm copy it and paste it. This is the observed value and paste it. So now what is the formula? The formula is here. I copy it and look at this. Paste it. This is the formula, observed, and there is no expected. So there is the observed numbers are total observed numbers. Total is equal to SU1 sum 150 and expected, therefore expected is equal to 150 divided by 5. Monday, Tuesday, Wednesday, Thursday, and Friday, 5 days a day. So divided by the 5 is the expected. So expected value is 30. All of the 30. Expected is 30. So now, what is the null hypothesis here? What is the null hypothesis? Null hypothesis, look at this. The headmaster expects that the students will be absent equally during the 5 days. This is the null hypothesis, okay? And if they are not equally absent, that will be the alternative hypothesis. That will be the alternative hypothesis. So we have to check it. And now we have to calculate the difference, this minus observed frequency as expected frequency, and drag it, we'll get these numbers. This is the observed frequency, difference between the observed frequency and the expected frequency. You can write here the difference between observed frequency and expected frequency. Okay, this column. And now you have to, it is the square of column 3, square of column 3. This is the column 1, column 2, column 3. So column square of column 3, and now equal to this, okay. Now we have to divide these numbers with the expected value. Expected value is 30, so 9 by 30. And the same way, (16 by 30). And now if you drag it, double click or drag it, then you get the value. Now, what is the total? Get the total, because you have to find out the sum. The total is the sum okay. The 4.2. Okay, chi-square is 4.2. So now look, this is the test statistic that is calculated, chi-square test statistics that is calculated, and look, this value is less than the critical value at 5% level. Is less than the critical value. Okay, 9.490. So what is the what should be the conclusion? Go to this. The conclusion is here. Look. What is the conclusion? What should be the conclusion? If the calculated chi-square value is less than the critical value, then you should accept the null hypothesis. Okay, we should accept the null hypothesis, as 4.2 is less than 9.490. We have to accept the null hypothesis. What is the null hypothesis? The null hypothesis is that headmaster expects the students will be absent equally during the 5 days. So students actually are absent equally during the 5 days. This is the null hypothesis. So we accept this. Okay. So this is the all about the chi-square distribution and chi-square test. And in this lecture, I try to cover the numerical part, and 2 problems are there. And if you go through very deeply this problem, then you can have a proper understanding of the chi-square distribution or chi-square test. Okay. Thank you for enjoying this lecture.